yeah, we are live. But this really, this personality suits you. Now your hairstyle and everything.
Lockdown effect. Thank you.
Lockdown effect. Great, great. So maybe I think, I can start with maybe introducing you.
Okay.
Like I said before, that you don't need much introduction in the industry, but for the benefit of people who are listening to us, I think I should do that. And so let me say that good afternoon, and this is the one of the very key subjects which we are going to address now, which is the standard fire rules across India, and to be presented by Abhijit Dandekar. He's the Director, Supply Chain, Quality and Product Safety, South Asia Pacific, Otis Elevator Company. He's an electronic engineer with a post-graduation in marketing management with almost 33 plus years of experience at Otis, spanning across various functions like R&D, field engineering, training, quality, product safety, lean manufacturing, supply chain and codes. A member of ET25, that is a P4 panel, Elevator and Escalator Code Committee of Bureau of Indian Standards. He has been licensed with government authorities for consultation on amendment to local elevator codes from Maharashtra and Gujarat state. He's also a member of CED 46, responsible for drafting National Building Code of India. He's a member of ISO TC 178 as well, representing India delegation for BIS in the past 6 meetings held at Russia, USA, South Africa, Australia, India, and Germany. Abhijit, it's an honor to have you here, and I'm sure it's a very interesting subject which you're going to touch upon. So I'm very sure that people will have a great takeaway from this. Over to you.
Thank you, Anita. I think I can share the screen now, right? So
yes, yes.
Okay, so I think we are going to touch on this subject. It has been a quite subject for a lot of people because most of them are not clear exactly on what are the current rules and then what is required exactly for a fire, for a fire lift, how it should behave, what requirements are there for a fire lift in a building, and in which building, which doors, which lift should be fire rated. Always a confusion everywhere. So I think apart from standard fire rules, I think I will touch on that subject as well. Coming to standard fire rules, why we need standard fire rules across entire India? Because there are two, three things. Number one, in India, we have state-wise configuration in the sense that every state has its own rule. It's not like a central rule like Indian Electricity Act or Motor Vehicle Act, something like that, which is valid across India. We don't have a central act or central rule for lifts and escalators in India, and that is the reason we have a problem in the sense we have rules in each state which are defined by that state's legislation or maybe the fire department. And then it becomes difficult for manufacturers or users or even firefighters. The worst thing is also the firefighters. They really may not know what exactly this lift is going to behave like. Because if they transfer from one state to another, it will be a different ball game altogether. So it is vital and very important that we have standard fire rules across India, and every manufacturer as well as every state should have a constant set of SOPs, what we call it, or standard operating procedures that are mandatorily should be followed by everyone, because there are this is a very sensitive subject, and in the interest of public security and in the interest of quick evacuation, this is extremely important. That's what I feel, and that is the reason we are touching on this subject. So let's go into details of this, how it started basically. Although there were fire rules and fire evacuation drills and fire procedures for lifts that were existing since the elevators were there, they were all varying in the sense that every company or every manufacturer will have their own software and hardware to deal with the fire situation, how the lift should behave in case of fire, And then it all started when in 2009, when on Diwali day actually, there was a fire in one of the buildings, and three firefighters actually lost their lives in a elevator cabin. And this is the exact photo of that cabin where this incident happened. Actually, this incident triggered that even the firefighters, which we thought were, well trained and basically they are well equipped, they lost their life, which was a really, really tragic scene. And then learning from these incidents, I think we should have a standard operating procedure for the elevators, and that is what was, thought, and the process immediately started on a very high priority. And then we started discussions with all the fire personnel in the state and different states, fire experts, fire consultants, and different manufacturers. So all together we decided, yes, this is a need of the hour, and then we should have a standard set of instructions which should be followed by the fire people, and all the companies or all the states should have a similar rule. That's what was the objective of this entire work that we were going to do. Then series of meetings were held between a lot of officers, fire officers, lift manufacturers, users, fire consultants, fire experts, and even port authorities, including Bureau of Indian Standards and the state legislation of state inspectorate departments. So a lot of meetings were held, and then based on everybody or other giving a priority to the fire people, because the firefighting is done by the fire personnel, and then we should listen to what they really want in doing this. And that's what was the major objective, that let's align to what fire people want, and then modify our each elevator software as well as hardware, so that we get this sequence the way the fire people want it, so that it becomes a standard rule. Now imagine if there is a fire in the building, and then if you are a fire person, you enter in the in the elevator. Now, if the standard rules are not there, you have to first of all look at which make is this elevator, and then, oh, this make, that means what should be the routine. You can't really know. You cannot keep on judging, or there can be confusion. There has to be a standard routine. There has to be a standard method of operating the lift. So that is the reason of all this standard operating procedure came up. Then it was decided to modify the Indian standards also, so that all these things what we are now talking about should be made mandatory, and then it will come in Indian standards, that is IS 14665, as well as in national building code. So we decided to include the same routine exactly, which was not there earlier in national building code 2005. So we said, okay, let's next revision we will include this routine, and even the Indian standard, which is most commonly followed in most of the states, which is IS 14665, that should also be modified to include this standard operating procedure, so that it becomes mandatory, at least in the states where these rules are followed. Now, I'll come to that which states, which rules are there, and how it differs, and what should be the objective. But before that, let's go through this incident and what exactly happened and what triggered the SOPs to be formed. Basically, use of fireman lift. There has to be at least one fireman's lift. Again, I will come to what fireman lift is and what are the extra requirements for the fireman's lift. So this should be only used in case of fire, and to be used by fire people only, and not by the residents. In case of fire, I will say. And all other lifts in the building should be grounded. That means they should not be left floating around in the building, but they should be brought down to the lobby floor or evacuation landing, what we call it as, and then they should be grounded. And only the fire lift, which is designated fire lift, and it has got some additional requirements, which I will talk about, and that should be functional, and that should be used only by the fire people. Now we need also a training to be conducted for all the fire people, firefighters across India, so that these new SOPs are known to them and it should be communicated to them. Because just making a set of procedures without people who are really wanting to know about it, then it becomes dangerous. So it's very important that all the people who should know about it are being communicated and trained on this standard operating procedure. So this is what all triggered, from an incident which was really tragic. And most of the time we are always reactive rather than, trying to mitigate. We always try to mitigate some faults which has happened and then correct the situation after some incident. So this is really not correct, but this is what is the current scenario is. So let's go to the primary reasons why this kind of incidents, the one we saw just now, can happen. Basically, it's building was not equipped with smoke sensors, sprinklers, CCTV, and remote monitoring devices, and any other equipment that is required, which can happen in majority of the buildings which are old. Even on the new buildings also this can happen. So they were not equipped with really a firefighting devices or smoke detectors and sprinklers, etc. That is the first thing of this building that was found. Then lifts could not be interfaced with all these advanced mechanisms like smoke detectors or even fire alarm systems and different fire alarms which are there in the building. So generally lifts should be interfaced to the system so that they are all automatically triggered, and all the lifts should be grounded automatically, with only the fireman lift in position now. So that should have happened, but in most of the buildings, because of rather in the absence of such equipment, most of the lifts are not interfaced, but they depend on the manual triggering of the switch. As you can see in the picture on the right, there is something called as fireman's switch, which is given outside on the lobby floor or the evacuation floor, and there is a switch inside that. It is a toggle switch, and then one has to break the glass to gain access to this toggle switch. So the hammer is also kept sometimes there, but many of the times it may not be there. So that also is another issue in many of the buildings. So first, this if there is no automatic system like smoke detectors or any fire alarm system which is interfaced to the lifts, someone or most of the time the fire people has to. They have a hammer with them always. They will break the glass outside and they will operate this fireman switch. This will enable all the lifts will be in the building should be grounded, and then that particular lift which is identified as a fire lift will now only be under their command. So that is what is required, but this particular building was not equipped with such devices. Then lift was not used by the firefighters. Again, there was not clear understanding with the firefighters which lift should be used in case of fire. So there were two lifts to three lifts in this building, and then they used the one which was available immediately after pressing the hall call. They really did not activate this switch, and they has not used the fire lift which they should have used. But that was purely out of misunderstanding and miscommunication as to what is required really to be done in the absence of standard operating procedures. Then fireman switch also was not activated. That means there is a special mode and a special program under which the lift is completely under control of the fire people. If you do not activate this fire switch, then the lift is not under your control. It just moves normal, like you move the elevator in a building. Like you are the user. If you want to go to 12th floor, you press the 12th floor button. If you go there, so it will function normally as if it is a normal operation. But when you operate this switch, it triggers another software routine or another program which forces the elevator to operate in a fireman mode, which is by which the entire control of the lift doors, its opening, etc., completely under the fireman's control. So this fireman switch was not activated, thus preventing the control on losing the control on the lift by the fire people. Also, they took the elevator to directly to the fire floor. That means if the fire was there on the ninth floor, they directly took to the ninth floor. So again, the standard operating procedure was not really clear or communicated that the lift should be taken two floors below the fire floor, and from there the firefighters are supposed to walk up with the equipment. So that is what was communicated, but not clearly as a part of SOP. So they took the lift directly to the fire floor. That floor was blazed in fire, and the moment the doors opened on that particular floor, the flames just came inside, rushing inside, and there was absolutely smoke and flames. All both came inside the elevator cabin, and it left with no room for these three firefighters who were there in the lift cabin, and they were charred to death, unfortunately. But really, we have got a lot of learning from that. So, fireman's operation, we have two different phases. I will explain that. What is phase one and phase two were not activated. Thus, they lost control on the lift completely. Lift doors opening and closing should have been in complete control of firefighters. But since they had not activated the fireman switch, they had lost this control. The doors automatically opened the moment lift came to that floor. As I said, SOP was not available and not communicated to everybody. Uh, they differed from lift manufacturer to manufacturer and even from state to state. That was the chaos which was absolutely created. And then the routine or the way the lift is supposed to behave in case of fire was absolutely varying between manufacturer to manufacturer and from state to state. So we all came together and said, okay, this what has to be corrected. First of all, we need a standard procedure. Number two, all manufacturers need to agree that yes, we need to modify this standard elevator software or hardware to suit the standard operating procedure, and then it should be communicated and trained by who are the available people in the industry, so that all firefighters are aware of this routine, and then they know exactly how to operate the firefighters lift or fireman's lift in a fireman's mode, basically. So this is all came out from incident which I just told. Now coming back to state variations, that is also another issue which we are trying to resolve through common code across India. That means we want to harmonize the standards across India, which is now really moving fast on a fast track basis. So if you see, we have 29 states in India, and out of these 29 states, we have rules or the lift rules in only 12 states out of that. That means we need inspections, we need licenses to operate the lift or to install a lift, and there will be licenses which are issued and renewed every year. But it is valid only in these 12 states, which is Maharashtra, West Bengal, Gujarat, Karnataka, Delhi, Tamil Nadu, Haryana, Himachal Pradesh, Assam, Gujarat, Kerala, and Jharkhand. So these are the only 12 states where we have lift rules. All other places we do not have lift rules in place. That means there is no inspecting authority, there is no licensing requirement. But as a responsible company, we should always comply at minimum to IS 14665 or the National Building Code of India or both. That's what is recommended. But in majority of the states, we have something called as Fire Prevention and Safety Measures Act, which is also another act which is running parallel to elevators. But that is written by the fire department, and it is applicable for the buildings. Not necessarily for only elevators. So it is applicable for the entire building as such. Elevators are also part of the building, so they have some lines or some paragraphs only on the elevator, but it very categorically says that all the requirements of a national building code should be followed in case of fire, and the lifts and the escalators, etc., should comply with the requirements of National Building Code of India. So automatically NBC requirements become applicable, and when the fire CFO issues an NOC to the building, they will definitely see the compliance to this requirement. And this new standard operating procedure is a part of National Building Code of India as well as IS 14665. So whenever we say that we are complying to these two requirements, automatically it means that the lift or the software and the behavior of lift in case of fire is in line with what has been documented in these two standards. But all other states, I would still say that we should still follow standard operating procedure. It doesn't at all cost much, and then we should have a safe and standard elevator across the country. And what actually happens is these rules in the states, like for example, the Bombay lift rule, which is in Maharashtra, or Karnataka state lift rule, or Gujarat lift rule, for example, they supersede all the standard. That means unless enacted, 14665 NBC are not the law in that state. So their standards that supersede the Indian standards or national building code. But that is where our role comes into picture, wherein we are now trying to align all the states to Indian standards or National Building Code of India, so that everybody has the same requirement. And happy to tell you that 5 states are already aligned to Indian standard, which you can see from this slide, like Karnataka, Kerala, Tamil Nadu, Haryana, and Jharkhand. These 5 states are already following Indian standards and National Building Code of India. Very soon, Maharashtra, Delhi, Gujarat, and West Bengal will also align. So this will make almost 80 to 90% of the elevator market under the purview of National Building Code of India as well as 14665. So that is really a great step that we are taking, so that we have standard rules across India rather than the state-wise regulations and state-wise variations in the requirements. It becomes difficult not only for the manufacturers, it becomes difficult for users, and it becomes really difficult for firefighters. So the idea behind explaining this is just for you to know which states have legislations, and then why we need a common rule, and how are we going to align, or how are we going to make this happen going forward in 2020 or 2022. Now, as I said, IS 14665 and National Building Code of India, or NBC 2016, were modified. IS 14665 Part 2 Section 1 was amended in February 2011. Only 2 years, it still took 2 years after that tragic incident for the amendment to release, even after it was a fast track project. So immediately, but at least we were able to release an amendment 1 to IS 14665 Part 2 Section 1, which detailed the standard operating procedure and what are the requirements for the fire lift and how the fire lift should behave in case of fire. So these two requirements were added to 14665 in 2011. And as we know that National Building Code doesn't revise so often, so the earlier code was in 2005, the next revision was in 2015. So we immediately said, okay, let's align even National Building Code of India to include these requirements, although it is for the building code, but it's being a very public security feature, we should also make it mandatory and standard from NBC requirement or NBC perspective. So even National Building Code of India, which was modified in 2015 but released in 2016, Part 8, Section 5A also was completely modified. And in that section, we had successfully included the same standard operating procedure, what is there in IS 14665 Part 2, Section 1. And that's how it became mandatory. As I said, in 5 states out of those 12 states where legislation is there in place, IS and NBC are the law. That means we need to mandatorily follow those requirements. In other states, not through Lift Act or Lift rules, but through Fire Prevention Act, it becomes mandatory, because Fire Prevention Act, as I said, says that in compliance to NBC is mandatory, and that is how it becomes applicable through National Building Code of India and through Fire Prevention and Life Security Measures Act, which I just mentioned. Every state almost has this act or and rules in place. You can download them from the internet. Just Google them, Fire Prevention and Life Security Measures Act for that particular state, and then you will find somewhere in between that one para somewhere that the lifts and escalators should comply with the requirements of National Building Code of India, 2016, 25, 2005, whatever it is, but it should be meeting the requirements. This also required, lift manufacturers in changing their software and logic to match the defined behavior of lift in case of fire. And we had almost referred to a lot of IBC, that is International Building Code. We had referred to international lift laws, lift rules, and almost aligned to international requirements now. So the new lift rule, as well as the routine and SOP that is given here, which will be standard, and in line with what is there in the international market as well, so that we should not be left behind, and we should not forget something which others have already modified, learning from the mistakes or learning from incidents or using their own expertise. So that's how I would say that this is the most current and most up-to-date standard for fire elevators. Now let's come to what are the requirements, because that is also very important. What are the requirements in case of fire? First thing that we all must know is that as per IS 14665 as well as National Building Code of India, NBC 2016 requirements, we need to have fire lifts in the building, definitely. But again, there is a misunderstanding as to which lift should be fire lifts, there should be how many fire lifts, and what exactly are the requirements. What about the other lifts in the building, whether they should have fire rated doors or they should not have fire rated doors. There's always a confusion amongst not only users, not only the builders, or even there's a confusion amongst the selling parties. So it becomes important and vital that I communicate very clearly as to what is the exact requirement, so that we are all aligned to the same requirement. The first thing, as per both of these standards, is that these rules are applicable for the lifts in the building having height more than 15 meters. That means any building which is taller than 15 meters, that means 5 stops, basically requires all these regulations to be followed. Now, what are these regulations? Number one, all materials of construction in the load-bearing elements, stairways and corridors and facade shall be non-combustible, including the entire building and the cabin and landing doors, etc. Then walls of the lift well enclosure shall have a fire rating of 120 minutes, that is 2 hours. And the lift well shall have a vent at the top of the area not less than 0.2 meters square. So this is the one requirement basically from the building construction point of view, which we need to tell as a manufacturers while building is being constructed, that these are the requirements for you to consider when the lift shafts are being designed or manufactured or made. Then again, I'll come back to this important point: landing doors. Now, lift landing doors shall be imperforate. That is the first requirement. Collapsible doors shall not be permitted, not allowed. Lift landing doors provided in the lift enclosure shall have a minimum fire resistance rating of 60 minutes. That means I will come to that. What is that fire resistance rating and with respect to what standard? But remember very clearly in your mind that if the building height is more than 15 meters, all the landing doors of all the lifts in the building, again I'm repeating, all landing doors of all lifts in the building should have fire rated doors of 60 minutes. Now there has to be only one fire lift. Okay, I'll tell you what extra requirements are there for the fire lift. Let's say there are 4 lifts in a building, and as per the rule, there has to be at least one fire lift in the building. But all the 4 lifts should have fire rated landing doors on all the floors. Okay, so again, I'm clearing this confusion, which is most commonly observed in during my experience with a lot of people, interacting with a lot of people. So they think only the fire lift should have fire doors. No, all the lifts of all the doors of all the lifts in the building having height more than 15 meters should be fire rated doors. Simple idea is that when the fire is on a particular landing, it spreads or propagates through the lift shaft as a, it acts as a chimney basically, and fire can spread fast from one floor to another if the landing doors are not fire rated. That means if only fire lift is fire rated doors and other lifts are not with fire rated doors, the fire is going to propagate through those doors. So it is very simple. The logic, please understand the logic. The logic or idea is to prevent fire from spreading, and that is the reason we need all the doors of all the lifts in a building having height more than 15 meters should be 60 minutes fire rated. Now, this 60 minutes does not necessarily mean by virtue of metallic properties, because I have seen many people saying that, oh, this door is a metal door, metal doesn't burn or it doesn't have a combustible property, so it is a fire door, fire rated. That does not mean fire rating. Okay, fire rating has to be tested in a laboratory and certified against certain standard. We just cannot say that because it is a metallic door, it is a fire rated door, and I can install any metallic door and then it can be called as a fire door. No, it is not like that. And that is the reason, I have also seen that people saying that I want vision panel in the door. But please understand, vision panel cannot be fire rated. Doors with vision panels cannot be fire rated for the simple reason that glass, when it is embedded into a metal frame, the coefficient of expansion of glass and metal are different. Metal will expand fast. It will crack the glass immediately, and when the glass is cracked, it will lose the fire rating, and that is how you cannot achieve a fire rating requirement of 60 minutes with a vision panel door. So obviously, vision panel doors are not fire rated doors unless they are glass doors and certified. So glass there is a very special glass for that, and if you use a glass door which are fire certified, they generally are almost 5 to 6 times expensive than normal glass doors. So beware of this fact that not every metallic door is a fire rated door. As you can see on the right hand side, there's a test photograph from a laboratory of how the landing doors are tested. They are really tested with real fire on, and when the fire is on inside, they measure that the flame should not come out, the smoke should not come out more than certain requirement, and then it should not allow the flame to pass through and propagate through the hoistway. It should not deform. It should not deform for more than certain. There should not be a permanent deformation more than 10 for the first 1 hour. It should not fall down, or the rubber part should not burn, so that the landing door comes down and then gives way for the fire. So there is a standard written for that. So whenever we say that the lift door is fire rated, it is typically tested in a laboratory, and this laboratory test is against some standards. Now, the valid standard in India now, which will be coming up, is basically ISO 3008 Part 2, which is an international standard. So we should have E60, that means integrity rating of 60 minutes. That's what we call it as. So minimum requirement of E60 as per the standard ISO 3008 Part 2, or BS 476 Part 20, or EN 81 Part 58. So either of these three standards as of now are valid in India for fire rating certificate. But going forward, that means once the new Indian standard, which we had just had a big seminar on this, on understanding of what new standard is coming out, and we also are now publishing a paper in EMA journal for everybody to understand what are the new standards which are coming out, new Indian standards which are coming out. They are aligned to international standards. So as per that, now we will require fire testing as per ISO 3008 Part 2 and BS 476 and EN 8158. And the minimum rating requirement is E60. That is the minimum requirement. Now, some tenders like metro stations or even airports and even some builders I have seen, they would specify that 120-minute requirement should be followed. That means instead of 60 minutes, 2 hours fire rating should be there. So they will also say that apart from integrity, radiation rating also should be achieved. So then it will become EW 120 or EW 16. There are various rating requirements in this standard, which I was just talking about, ISO 2008 Part 2. So we can just go through that standard, and what is required is minimum E60 rating certified. Now, certification is very important. Certified by a approved laboratory, that it meets the requirement of E60 rating as per either of these three standards. That certificate must be available with you, because nobody is going to ask that, but that is for your own safety and for the people's safety, that your doors are really fire rated and fire tested, rather than just metallic doors used and we saying that they being metallic doors, they are fire rated. No, it's not like that. We need a lot of modifications to be done in the door designs, the rubber parts, the polycarbonate parts, the shields, the flame should not pass through the gaps on the sides. So we need a lot of coverings on the sides. So, all these things are required to be done in the design changes also are required to be done. Sorry. The number of lifts in one row for a lift bank should preferably not exceed 4, and total number of lifts in the bank of 2 rows shall not be 8. So, the firefighter should not be running around in the building. If the fire lift is on number 16 in the row, it should not be like that. Should be easily accessible from the evacuation landing. Now, evacuation landing means, that is also defined in the standard, where the fire engine can come in. There can be two basement parking, but the lobby is on the third level actually, and fire engine can directly come on the third level. Then evacuation landing is called as third landing is the evacuation landing, which is the lobby, not the parking floors. That means the fireman switch, etc., everything should, or a smoke detector, whatever you are going to put, should be there in the evacuation landing. And the rule of 15 meter is applicable from evacuation landing and up, not below that. So if it's a five-stop building, it's under 15 meters. So five with two basements also called under 15 meters, because we are calculating the height from the lobby or the evacuation landing and up, so that you should be mindful of. Lift car door, again, very important subject. Lift car doors shall be imperforate. They should not be collapsible. Collapsible doors are not allowed. And fire rating is not required for the lift car doors. Landing doors, yes, but car doors, no fire rating is required. And it's not possible to generally provide because of three reasons, basically. Because number one, first of all, when you operate, whenever there is a fire, you are going to operate, the fireman is going to operate the fireman switch. The moment the fireman switch will operate, I will just come very in a detailed SOP which is there. All the lifts are going to be grounded. That means they are going to come to the lobby floor or the evacuation floor. Thus, they will be removed from the fire scene immediately. So we don't need a fire rated door. Also, the material inside the cabin, we are not saying that the fire will spread from the elevators, but what we are trying to prevent is fire should not spread through the shaft, as a chimney, because the shaft will act as a chimney and fire will propagate through the lift shafts. We are trying to prevent that. And number three is car door does not have a lock by standard requirement. That means if somebody forces open the car door, it can be opened manually with certain force. The moment you open it, automatically the fire rating is lost. It's meaningless basically. And that is because of these three reasons, lift car door is not required to have a fire rating, but it can be metallic so that the radiation can be avoided, the heat transfer can be avoided. So this is again another confusion or misunderstanding between the users, builders, as well as the lift manufacturers. I'm just trying to make it very clear that all landing doors of all lifts in the building having height more than 15 meters should be fire rated, and that fire rating should be certified to either of these three standards: ISO 2008 Part 2, BS 476 Part 20, or AN 81-58. And minimum requirement is E60 rating as per this. So I think I have made it pretty clear, and this confusion should be now avoided. Again, vision panels cannot be used for fire lifts because they cannot be fire rated. The simple design of it, if there is a vision panel, it is not fire rated design at all. We don't have a single manufacturer in India who has vision panels, those which can be certified for fire rating. Yes, glass doors can be, but glass doors, as I said, we need a certification, and that special glass, the doors with that glass will be almost 5 to 6 times expensive. But yes, glass doors are available, but those with vision panels are not possible to have fire rating requirement. Again, and additional requirements are like, use of telephone or any communication facility must be there in the lift car and between the main lobby, between the machine room and communication system, or maybe even a EPAX connected system also should be used. But at minimum, there has to be a battery operated intercom system, or to be communicated from lift cabin to either the lobby security or to the machine room, whichever is all three places. Then then number two, again very important, all lifts, whether fire lifts or non-fire lifts, shall be provided with emergency service phase one. Now, what is phase one? I will just talk about it. But remember that all lifts must have phase one operation into it. They must be programmed to perform phase one operation upon activation of the switch, fireman switch, which is there. Grounding operation may be initiated by individual switch or a common switch. I would recommend it's a common switch for the entire building, so that with a one flick, the firefighters can bring all the elevators down and only the fire lifts in the building should be operational. So there is a mistake proofing. There is no way that the firefighter can now take the non-fire lifts up, because they will not be operated. Only the fire lifts will be operated once the switch is activated. Now, as I said earlier, there are additional requirements for the firemen. Now, what are those requirements? The fireman's lift is provided in the building for the purpose of aiding firefighters, not for the use of common public. Remember this. This is not, if the fire lift is there, that should not be used by normal public for evacuation. It is always said that you should not use the lift when in case of fire. You should use the staircase, which have got fire check lobbies, and they are prevented from smoke exit windows, so you are much safer there. But if you use a very high rise building and super tall building, the law is changing. But at the moment, we still say that use staircase, do not use lift. Normal people, but this can be used by firefighters, firemen for mobilizing their equipment. There shall be at least one fireman's lift per building. If there are multiple wings in the building, then each of these wings should have at least one fireman's lift. So this is what is the law says, IS as well as National Building Code of India. Now let's come to what is phase one and phase two operation basically, and what are the fireman's requirements. Now the fireman's lift shall have following additional requirements. The fire lift may be used by the occupants in normal operation, in normal times. But in case of fire, they should not be used. They should only be used by the fire people. Now, fireman's lift shall be provided with a fireman's switch, which is toggle switch. I just showed the photo, which is on-off switch, and which is clearly marked, and it should be there at the evacuation line. Now, the moment I say evacuation landing, it means where the fire engine can come. The basements cannot be evacuation landings, because fire engine cannot, for the simple reason that the fire engines cannot go to the basements immediately. The first accessible floor, which is lobby floor, and it should be directly where the fire engine can come in, should be called as evacuation floor, and the switch should be located there. The switch shall be situated in the glass fronted box and clearly marked, and then you have to gain access. And then once you activated this switch, it should be left in on position. Now, even if somebody turns it into off position, the functioning which I am just mentioning next should not be disabled. That means only when the lift is at the evacuation floor or the lobby floor and the switch is turned off, then only it will come out of the fireman mode. If the lift is at some other landing, and let's take an example. If there is a fire and fireman comes and operates the switch, and then he takes the control of the lift, he goes to the floor where, or two floors below, where there is a fire, and now he has parked the lift there, and then some Charlie comes in the building and turns that switch off. The lift will start working in normal mode, and then the fireman will be trapped there on the land. This should not happen. That is the reason now the control of this switch is rendered ineffective. That means it will not function now. It will not function till the lift comes back to the lobby floor or the evacuation landing. Then there has to be an audio and visual alarm in the lift cabin, which tells that the fireman switch has been activated. Now, if there are people in the lift, they will be warned that the fireman will be activated. Do not panic, because now the doors will not open. The lift will stop and move to the ground floor, and then only it will open the doors. So they should not be panicked. All the calls will be cancelled, because when the people get panicked, they start pressing the buttons on the operating panel, but none of the buttons will be working now. So that is the reason the alarm has to be there to indicate the people that there is a fire in the building. Fire routine has been activated, and the lifts will be rushing down to the ground floor. The fireman lift shall have minimum floor area of 1.43 square meter. It should be having minimum capacity of 8 passengers or 544 kilograms, since we have 68 kgs per person in India. Also, if the building height is more than 60 meters, lift cabin should be minimum 1000 kg. Now, the fireman's lift shall be provided with power operated doors only, not manual doors, and vision panel should not be there in the power operated doors. That is the requirement in Indian standards. The speed of the fire lift shall be at least 1 meters per second, but it should be such that the lift should be able to reach from ground floor to the top floor in less than 60 seconds or 1 minute. That means with 1 MPS, you can maximum achieve a height of 60 meters. And then if the building height is more than 60 meters, automatically or naturally you will require higher speeds. In case the building is zoned, then the fireman's lift shall be operated from the lowest serve landing to the topmost serve landing in that zone in 1 minute. Then the words fire lift shall be very clearly displayed in fluorescent paint on lift landing doors on each door. That this lift is fire lift, and it should be fluorescent paint so that even in the emergency light or in case of darkness, it should be easily seen. We should also have reliable alternate source of power in the building for the fire lift at least. So these are the requirements only for the fire lift. As I said, there can be 5 lifts in the building, and 1 lift has to be fire lift, and these additional requirements must be there or must be provided for that fire lift. Sorry. Now let's come to phase 1, phase 2. This is the SOP that we are talking about, and this is very important for everybody to know, because if any of the lifts by any manufacturer is not complying with this, I would rather recommend to modify the hardware and software to suit this, because this is in the interest of public safety as well as in the firefighter safety also, because they should not they should not remember which manufacturer it is, what process it should follow. The process has to be standard. Now, let's say that, as I said, whether the lift is fire lift or non-fire lift, this phase 1 operation is mandatory for both the lifts. Phase 1 means what? It should return to evacuation floor immediately. So let's see, if the lift is traveling up with passengers and somebody operates the fireman switch, all the lifts in that building should stop immediately on the, not emergency stop, but it should normally slow down and stop on the next landing. Without opening the doors, they should come down to the lobby floor or the evacuation floor. The moment you operate the switch, let's say there are 3 lifts in a building, and if the fireman operates that switch by breaking the glass, and then all the 3 lifts, whichever position they are, they will slow down and stop on the next floor without opening the doors. If they are going up, they will stop and reverse the direction and come down to the evacuation landing. If they're already going down, they will cancel all the calls, and without stopping, they will continue going down, but now they will go to the evacuation landing or the lobby straight up. This is what is required. All the calls will be cancelled, and no other calls from inside will be now registered. There will be fire alarm inside, and they will be brought down immediately. And now, once they are at the lobby floor or the fire evacuation floor, all the lifts which are non-fire lifts shall remain parked at that floor with doors open. Okay, that means no calls will be registered from inside. They will just evacuate the passengers who are there inside the lift. They will be brought down, parked there with doors open. Now, only the fireman lift, which is identified as a fire lift with these additional requirements, as I mentioned earlier, will now be operational. And now the phase 2, that we call it as, only the fire lift enters the phase 2. All other lifts which are non-fire lifts should stop their operation after phase 1. Now phase 1, as I said, is very clear, which I just explained. Audio visual alarm inside the lift, they will stop, cancel all the calls. If they are going up, they will stop on the next landing and return back to lobby. If they are going down, they should cancel all the calls without opening the doors. They will go to the lobby. And then, very important thing, if there are any smoke detectors, if there are any infrared door sensors to keep the doors open, then those shall be rendered ineffective. That means those should not be functional now. That means because of the smoke, we are seeing that because of the smoke, there is an opaqueness, and then these infrared sensors will falsely detect it as somebody is in between, and the lift will, will not close the doors. So it is very clearly written that all hit and smoke sensitive door reopening devices shall be rendered inoperative. And if the lift is traveling towards evacuation floor, as I said, it will continue to move in that direction. And the continuous audio signal now will be turned off once it reaches the evacuation landing. Now, if the building is designed for alternate evacuation floor, imagine that there is a fire in the lobby itself. Now, what we have done, the people were safe on the top, and then by virtue of activating the fire switch or through an electronic smoke detector, you have brought all the elevators down and opened the doors there, and you have brought all the people into a fire path. So it is very dangerous situation. So we must detect by virtue of smoke detectors which floor the fire is, and if the fire is on the lobby or evacuation floor itself, then the lift should not come to lobby or evacuation floor. It should go to alternate floor, which is generally one or two floors above the lobby floor. So there we generally give ASL or alternate service landing, what we call it as. There are two, ASL1 and ASL2. That means if there is a fire in the lobby, it will go to ASL1. If there is a fire in the lobby and ASL1, then it will go to ASL2. So that must be also programmed into the elevators. Now, what is phase two? As I said, all the lifts, whether fire lift or non-fire lift, shall come down upon activation of the fireman switch. And now the non-fire lift shall park with doors open, and the buttons inside will not be functional at all. Now only the fire lift. As I said, there are additional requirements for the fire lifts, like it should have auto doors, it should be minimum area, passengers 1.43 square meters, it should have 1 mph speed, it should reach from top to bottom in 1 minute. So all these additional requirements which are there, now that particular lift, which is identified as fire lift, now only should be functional. Now the lift does not respond to landing calls but registered only the car calls. Now outside calls will be disabled and only the calls from inside will be operative. Now there is a hitch in that. Okay. Now only one car call will be allowed now to be given. Let's say if the fire is on the 9th floor, and as per the standard operating procedure of the firefighters, it says that you must stop 2 floors below the fire floor. That means now he is supposed to register a call of 7th floor. So only one call at a time will be taken up. No other calls. You cannot press multiple calls, 4, 5, 6. You cannot just press like that. There has to be only one call which is pressed. Now, let's assume that by mistake the fire is on the 9th floor and the fireman presses 9th floor button in a hurry. Now, actually, what will happen? He will go in that landing, at that floor, and now he suddenly realizes after the lift has started, oh no, I pressed the 9th floor button. Nothing goes wrong. There are two protections I will just explain for him. Number one is now he can give any floor lower than that. That means even if he has pressed 9th floor, call is registered, lift has started moving up. Now he suddenly realized that 9th floor itself there is a fire. He should have pressed 7. So now he will press 7. So the moment the 7th floor also will be registered, but the lift now will stop on the 7th floor and it will cancel 9th floor call. So all the lowest floor call it will take and it will cancel all the calls. So there's one more additional routine which is required. Now, whenever the fireman presses a car call, let's say 9th floor, the doors will not close. This was a very biggest modification which was required. Because many manufacturers require the same car call button to be pressed. Somebody wanted door close button to be pressed. Somebody wanted something else to be pressed. It cannot be different from manufacturer. It cannot be different from state to state. So now we have said that as a standard, many of the lifts do not have door close button. So we said that for the standardization purpose, let's keep car call button itself pressed. That means the moment the firefighter enters and if he wants to go to, let's say, seventh floor, since the fire is on the ninth floor, he will give a call for seventh floor button. But if he releases the call will get cancelled and the doors will not open. So he has to keep the seventh floor button pushed continuously, and then and only then the doors will start closing. And if he releases the button in between, the doors will again reopen. So he has to keep the button pressed till doors are fully closed. And once doors are fully closed, he can release the button and only then the call will be registered. And only after that, he can give a second lower call, not higher call. He can give a second lower call if he wants to change his mind. So this software modification or logic modification is required. Now, as I said, it will go to the lowest call which has been given and it will cancel all other calls. Now, let's say now if he goes there on the seventh floor. On the seventh floor, if the lift reaches, lift will stop, but the doors will not open. This is the modification. Again, we heard on learning from the earlier incidents. When let's say if there is a fire flames already there outside, the moment the fireman goes there and lift doors open, the fire will come inside, and that can be disastrous for the fire people. So now we have given complete control by software. The doors will not no longer open. Now he has to keep door open button. He has to press the door open button, and he has to keep it pressed. The moment he presses door open button, the doors will start opening. And if he sees there is a fire, he will immediately, as a reflex action or purposely, he will release the button. The moment he releases the button, door will close again, and he can take the lift to any other line. But now there is a protection added, and this is what is very important, that the door open button must be continuously pressed till the door completely opens. Now once the door completely opens, the lift will remain parked there. It will not return to the any landing, and then till the fireman comes in and he wants to go to another landing or wants to go to lobby, then only it can be functional. But and then additional requirement for the new now we have got destination control lifts. That means there are calls which are given from outside. There is no car operating panel or no COP inside the lift. So in that case, all the fire lifts must have a fully functional car operating panel. It cannot be, even if it's a destination control system, there has to be a COP in the car. Maybe in normal operation, the COP will be not functional, but in case of fire, the COP is required to be in operative condition. So for fire lift, there has to be a COP if it's a destination control kind of elevator. And these are all the modifications and requirements that each manufacturer has to make so that this routine becomes standard and common across the entire country. So this is all about the standard routine that we are now talking to all the fire people. We are talking to code authorities, and everybody has approved this mechanism. As responsible manufacturers, most of us have already modified all our softwares and hardwares or logics that we are using in the elevators to suit this new well-defined standard operating procedure. But if not, then I would urge everybody to modify this. This is already there in the presentation, but you can always refer to IS 14665 or the National Building Code of India 2016, where all these things what I just mentioned have been very clearly written and explained. So you can just follow that requirements. At minimum, that's what we are saying, that for all the lifts having height more than 15 meters, there has to be fire rated doors for all the lifts, all the landing doors, and those should be certified E60 as per ISO 3008 Part 2. The walls of the building should be 120 mm rated, and there has to be a smoke vent on the top, not less than 0.2 square meter. Then standard operating procedures for fire personnel must be documented, communicated, enforced across the country, which is now already been completed in almost all the states. Through NBC, there have been NBC seminars across the country conducted by BIS, and then it has been very clearly communicated. EFS phase 1 and 2 operation to be standardized amongst all lift manufacturers and amongst all states. State authorities should also standardize, which has already happened, and now it can be standardized across the entire country. And then compliance with Indian standards to be made mandatory, maybe as a central act, as I said, similar to Indian Electricity Act or Motor Vehicle Act, there has to be a central act on fire as well as elevator usage. And as I said, those must be certified for E60 rating. And the standards which now are getting harmonized, the major role is being played by ISO, which is International Organization for Standardization. India is a founder member of ISO, and that is why we always follow all the ISO and IC standards into our country, which are direct, our representation is there in that committee. BIS, which is a standards body in India, or Bureau of Indian Standards, is a founder member of ISO, and that is how we get most of the ISO standards as international standards, which can be adopted straight away in India, and that's what we are now doing, so that the rules become common across India, and they are aligned to international rules, so it becomes standard across the world for going forward. So that is the objective, and we are. This is not easy. We all started it, as I said, from 2009. We almost, almost 12 years or more than that into this. A lot of efforts have gone in, a lot of man hours have gone in, documentation, communication, training to these people, and that is how it has eventually come into existence. But we would again, as I said, urge every manufacturer to align to the standard requirements, be aware of what are the requirements, and then comply with it, because it is in the interest of public safety, it is in the interest of fire people safety. So we should not compromise anywhere on this requirements just for the sake of somebody is trying to take a risk over there. So that is about all these things, and then that's how we have progressed towards standard fire rules across the entire country. Thank you very much for patiently listening. And over to you, Anita, if there are any questions and answers.
Thank you, Abhijit. Thank you so much for this great insights. I think this is a subject which continuously needs to be addressed at every time and at every levels. And I know you all are doing a great job. The entire committee is doing a great job, and we would like you all to, from time to time, participate in the, Elevate World India magazine, and keep giving the information as and when you feel it is necessary to be communicated. Right now, I can't see anybody asking you anything, but we will share this presentation also over our other, social media channels and all that, and people can reach out to you. We'll put the communication to reach out to you, and then if they have anything more to know, they will definitely come back to you, Vijay. Thank you so much.
Sure. Thank you very much for giving the opportunity so that this important topic is well communicated across. Thank you.
Yes, yes. Thank you. Thank you for this detailed